Hello, this is Andy Schweitzer and a little video here on acid-base reactions. This is a video somewhat based off an old AP exam style where they had you translate and write out chemical reactions. We still do this quite a bit in chemistry. So this is a little preview in what we would see for these and how would we tackle some of these problems. First of all, when we look at an acid-base reaction, want to be aware of some of the key players here. Strong acid would be my 6 strong acids. Hydrochloric, hydrobromic, hydroiodic, hydronitric, nitric acid, sulfuric acid, and perchloric acid. These are our strong acids. By definition, they ionize 100%, and we would therefore write any of these. If we're looking for a net ionic equation, we would list these guys as being separate. HI would be H plus and I negative. HNO3, H plus, minus. So weak acids would be a little different. We have, and there are lots and lots of weak acids. There are some that are more common than others. I would say, for example, ammonia and ammonium. Ammonium is a weak acid, and its conjugate is ammonia. Very common. We have organic acid, like let's say vinegar, which is HC2H3O2. Its conjugate would therefore be C2H3O2 negative. This is an organic acid, which looks like this: carbon, carbon, OH, double bond O, and then H is here. So the only difference between this organic acid and another one is the chain could be longer or it could be shorter. This right here is our carboxylic acid. Anyways, there are lots of acids that you could do. HF, for example, is not that common, I don't believe, in industry as much as it is just in these problems. You see them this one around, and there's lots of acids and weak acids. These are some of the more common ones. A couple types of chemical reactions that I would like to highlight here that I just see very often. In one of the more typical ones would be something where we have a strong acid reacting with a strong base. In this case, we would have, let's say, HCl. I'm just going to type this in here. We could do, for word-wise, hydrochloric acid is mixed with sodium hydroxide. All right, so there's two strong acid and strong base. So when I write this out, it's going to be H plus Cl minus plus Na plus COH negative. H and OH will form liquid water, and at that point we'd have the Na plus ions and the Cl negative ions still floating around. So if we were to make this a net ionic equation, we would be H plus OH negative yields H2O. You should note that in reality, any strong acid with any strong base, you get this same net ionic equation. If we were to take a strong acid plus a weak base, or I often refer to as a strong and a weak, the strong can protonate the weak or vice versa. So here would be an example of that. Would be hydrochloric acid is mixed with we could do sodium fluoride. All right. So what would this be? We have a situation where we have a strong acid, and I would be looking to protonate something with that, and we have a weak. Well, this technically is a weak base. So any strong acid can protonate any anion. So it's going to be H plus Cl minus plus Na plus F negative. This will protonate the strong, will protonate the weak, and we'll get my overall H plus F negative will yield HF. Any strong can protonate any weak anion. And finally, we have situations where we have polyprotic acids. So a polyprotic acid, okay, might be a situation where we have equal volumes of equal concentration of NaOH and let's go with phosphoric acid. In this case, we have an acid, weak acid, and a strong base, but this acid is polyprotic, so it's going to be an OH negative. I will be deleting the Na off of here. Plus my phosphoric acid. It's a weak acid, so I'm going to be writing it together. PO4. And they're equal volumes of equal concentrations, means that molarity equals moles per liter. Equal molarity, equal volume means equal moles. So in this case, I only have enough hydroxide to knock off one of the H's. It would be H2O is the result of neutralization, and then H2PO4 minus 1. Oops. This is my reaction. There we go. We could have another situation where we have, okay, excess sodium hydroxide is added to phosphoric acid. In this case, it's going to be slightly different, where we have now excess hydroxide, so it's going to be OH negative plus H3PO4 will yield H2O, and then PO4 minus 3. And 3 of these and 3 of these would balance it. And that is it. There are a couple other small reactions that at this point I'm not going to highlight too closely yet, but main thing to keep in mind is these simple type of reactions, along with the fact that we're pretty common players here as far as ammonia, for example, and ammonium. We didn't use those. Those are very common in acid-base reactions. Thank you.